Welcome to episode 4 of A Divisor Failure Analysis Case Study. This investigation is done for a failure of roller shaft on the cement kiln. The Hill Cement investigation team was made of Sawan Jasolia, acting as facilitator and mentor for the investigation, Arnab Khonar, acting as team leader, and Varun Singh, Ram Rai, Sridhar Jena, and Satish Sharma as participants to the investigation team. The failure happened on the roller shaft on the outlet end of kiln that caused 72 hours of downtime and production loss. This failure also happened in past and thus required an investigation. Review of the kiln history revealed that soon after commissioning of kiln in August of 2009, there were frequent stoppages for multiple reasons. As a result, the kiln went through a lot of hot stoppages, resulting in minor plastic deformation and shell distortion ranging from negative 8 mm to positive 32 mm between location 5.7 meter to 15.6 meter from outlet end. At the same time, the outlet end tire was wrongly commissioned and the tire used to be overhung up by 150 mm uphill side during hot condition. This led to uneven load distribution among the three tires. Also, in August of 2015, kiln shed fell over the girth area and resulted in deformation of two spring plates of the girth gear. The event sequence shows that 15 days prior to the failure event, high vibration was observed and aggravated to heavy cranking noise coming out of the roller shaft. The unit was shut down and handed over to maintenance. The unit disassembly shows complete damage to the bearings and flexing of shaft. We started with the standard bearing and shaft failure template out of A Divisor software suite and checked for verifiable outcome for all the 29 primary causes for the two failure modes. Checking against each one with evidences in history and failure events, upon validation, it was clear that loss of refractory on kiln internal triggered the failure. The nature of the failure was not immediate, instead, it triggered many other factors that led to both flexing of shaft and damage to the bearing. Kiln refractory was lined 5 years ago and has been performing moderately well. Over past year, hot spots were observed in 3 locations, one of them close to the roller. In past few weeks, the hotspot zone near the roller unit has been spreading and the unit was exposed to radiating heat. Combination of high surrounding temperature, shell and tire ovality, and kiln crank cause heavy and uneven mechanical loading on the bearing and shaft led to bearing damage first and later shaft was damaged as a secondary failure. From the above observation and logic tree, it is concluded that the primary reason for failure is loss of refractory and the secondary reason is uneven coating on the shell internal. It is obvious that we now have a deformed kiln and thus some of the control must be procedural rather than a corrective task. It is important that operations follow a proper shutdown and startup cycle as it has major impact on thermal behavior leading to shape deformation. Ensuring good application practices of refractory and drying timing and burner alignment will play a crucial role in the refractory life and damage. Skewing roller support for uniform and even loading is also necessary and was recommended to be included in the preventive maintenance task. To conclude, the refractory failure of kiln is basically the result of 5 events: uneven burning flame distribution, shell deflection resulting poor fixing of refractory, mechanical vibration, wrong selection of bricks at wrong position, that is with respect to alumina content, poor quality of bricks. If we can strictly maintain the parameters of the above mentioned points, we can avoid such failure and have better reliability of kiln. Once again, thanks to Sawan Jasolia for providing his insight on kiln operation and thanks to Hill Cement team for using A Divisor failure analysis software and methodology for solving their chronic problem.
Thank you for watching this episode. To watch more such episodes, you can visit failure analysis page on advisor.com and feel free to write to us at support@advisor.com if you wish to jumpstart your APM journey.